So hello everyone, I am Lavesh Vyas and today we will talk about basics of MapReduce programming. So MapReduce is a powerful programming model that enables efficient distributed data processing on large scale datasets. In this presentation we will explore the fundamental concepts, job execution, flow, advantages and common use cases of MapReduce. So here it is the MapReduce architecture client, then job, then Hadoop MapReduce master. From there, it is divided into two job parts. From there, input data is fed to map, then from reduce, then from output data. Now, talking about what is MapReduce. MapReduce is a programming model used for efficient processing in parallel over large data sets in a distributed manner. The data is first split and then combined to produce the final result. The libraries for MapReduce is written in so many programming languages with various different optimizations. Now, talking about components of MapReduce architecture, the client, then job, then Hadoop MapReduce master, job parts, input data, and output data. So now, first let's talk about client. The MapReduce client is one who brings the job to the MapReduce for processing. Now, the MapReduce job is the actual work that the client wanted to do, which is comprised of so many smaller tasks that the client want to process or execute. Hadoop MapReduce master. It divides the particular job into subsequent job parts. Job parts, the task or sub jobs that are obtained after dividing the main job, the result of all the job parts combined to produce the final output. Talking about input and output data, the data set that is fed to the MapReduce for processing is input data, and the final result obtained after the processing is output data. Talking about parallel processing, MapReduce divides a large dataset into smaller chunks, which are then processed simultaneously on multiple nodes in a cluster. Two-phase approach. The map phase applies a function to each data chunk, while the reducer phase combines the result to produce the final output. Now, talking about key concepts, mapper, reducer, and shuffling. Mapper, the mapper function processes input data and generate key value pairs. Talking about reducer, the reducer function aggregates and processes the intermediate key value pairs. Talking about shuffling, the shuffle phase group all the values associated with the same key and sends them to the reducer. Now, moving on to the next slide, input and output in MapReduce. Input. MapReduce processes input data that is typically stored in a distributed file system such as Hadoop file system. Hadoop distributed file system basically. Output. The final output of MapReduce job is also sorted in a distributed file system, making it accessible for further processing. Flexibility. MapReduce can handle a wide range of inputs and output formats, from structured data to unstructured text and multimedia files. Talking about scalability, the distributed nature of MapReduce allows it to process huge datasets efficiently, scaling with the size of cluster. Now, MapReduce job execution flow. Now, first is input. The input data is split into smaller chunks and distributed across the cluster. Map. The mapper function is applied to each data chunk, generating intermediate key value pairs. Talking about shuffle, the shuffle phase groups all values associated with the same key and sends them to the reducer. Reducer. The reducer function aggregates and processes the intermediate key value pairs to produce the final output. Now moving on to the next slide. Advantages of MapReduce. The first is scalability. MapReduce can handle large-scale datasets by distributing the workload across a cluster of machines. Now, second is fault tolerance. If a node fails during the computation, the system can automatically re-execute the task on the another node. Simplicity. The simple programming model allows developers to focus on the core logic of their application. Now, data locality. Data locality. MapReduce programs are stored on the same servers as the data, so data can be processed more quickly. Talking about flexibility, MapReduce can store and process data from different sources, including unstructured data. Now, talking about last but not the least, cost effectiveness. Cost effectiveness. MapReduce is an open source program that can save on software expenses. Since it's an open source, it is free of cost. Now, moving on to the next slide. Challenges and limitations of MapReduce. The first is latency. MapReduce is primarily designed for batch processing, which can lead to high latency for real-time application. Data skew. Uneven distribution of data can cause some reducers to take much longer than others, leading to performance issue. Complexity. Debugging and optimizing MapReduce jobs can be challenging, especially for a large scale and complex application. So MapReduce is quite a complex thing to do. Now talking about limited data types, MapReduce is primarily designed to process structured data and may not be well suited for handling unstructured data types. Now moving on to the next slide. Common MapReduce use cases. There are different use cases of MapReduce. The first is web crawling. MapReduce is often used to build web crawlers and search engines, processing large amounts of web data efficiently. Web crawling, or we can say web scraping. Map reducers are generally used in web scraping the data from different search engines or different websites. Now, the second is log analysis, collection of log data, then cleaning of data, converting into structured data, then analyzing the data, then obtaining the significant result. And these all are stored in application data, database, network data, configuration files, and performance data. So log analysis. MapReduce is well suited for analyzing large log files such as server logs to extract valuable insights. Now, the last but not the least, there are many other applications, but for the machine learning, which is a very important one, MapReduce can be used to train and deploy large-scale machine learning models on a distributed data. So MapReduce can also train different models. It can deploy large-scale machine learning models. Now moving on to the next slide. MapReduce frameworks. There are different MapReduce frameworks. The two top are Hadoop and Spark. Hadoop. Hadoop is most widely used open source implementation of MapReduce programming model, providing a scalable and fault tolerant platform for distributed data processing. Hadoop is also an open source program, open source projects, making it fairly cost effective to use. And the second is Spark. Spark is a newer open source framework. This is also a free and open source that extends the MapReduce model, offering improved performance and support for real-time stream processing and interactive queries. Now, last but not the least, the last slide of our presentation, best practices for effective MapReduce implementation. So there are different practices for effective MapReduce implementation. These four are just the common ones. So basically optimizing input and output. So choosing appropriate input and output formats to minimize data processing overhead. This is one of the approach. Second is partition and sort data. Partition and sort the input data to improve the efficiency of the shuffle and reduce phase. Third is leverage caching. Utilize caching mechanisms such as Hadoop's distributed cache to improve performance for repeated jobs. And last but not the least, fourth one, monitor and tune. Continuously monitor the performance of MapReduce jobs and optimize the configuration based on the observer bottlenecks. So this is the end of presentation. So at the end, to conclude, MapReduce programming is a powerful framework for processing and analyzing massive datasets in a distributed and scalable manner. It breaks down complex tasks into simpler map and reduce operations, enabling efficient parallel computation. By focusing on data locality and fault tolerance, MapReduce ensures high performance and reliability, making it a key tool in big data ecosystems like Hadoop. Its application range from indexing web pages to analyzing user behavior patterns, demonstrating its versatility in solving real-world problems. In essence, MapReduce has revolutionized the way we handle large-scale data, paving the way for modern data-driven innovations. By abstracting the complexities of distributed computing, MapReduce empowers developers to focus on data logic without worrying about the underlying infrastructure. It has laid the groundwork for newer big data tools and frameworks, showcasing its enduring significance in the data science and technology landscape. So this is all from my side. Thank you for listening to me. Thank you.